That's the other alternative lah. Do as much as well as possible lor. Concentration of paper four lor. Okay. Anything you want to ask or anything you want to tell me?
No.
Okay. From 2025, it looks like there are four variants. And usually variant 41 and 43 are the same lah. You can check through lah. I check the first question, it looks the same, so I didn't check the others lah. I assume it's the same lah. You can check and let me know lor. Okay, let us make a start. There is the variant 41, May, June 2025. Define gravitational potential.
Work done by unit mass in moving an object from infinity to origin, defined point within the gravitational field.
Work done per unit mass, that must be in lah. That's the first point lah. Work done in moving mass from infinity to the point lah. You can combine them together lah, but that's how they will mark lah. Okay, let me ask you a question. For a solid sphere, what is the potential within the sphere?
What do you mean?
For a solid sphere, what is the potential within the sphere? Is it constant? Is it zero? Is it exponential or what? Yep. I'm revising with you.
But what is the potential between the sphere?
Potential within the solid spherical conductor.
Forgot.
Constant, no? Okay,
Constant.
for
Okay.
a spherical conductor that is charged, where does the charge reside? Where does the charge reside on the spherical conductor? All this must be by your fingertips already. Can reside at the surface, oh? They repel each other. Surface is where they can be as far as possible from each other. So what is the
Oh, okay.
electric field strength within the sphere?
Like the number?
Say again.
You mean the
Electric field
zero?
strength
You want me? Is
within
it
the
zero?
spherical conductor. B zero.
Uh,
B zero.
Zero.
The electric field will cancel off.
Yeah, zero.
Okay, let us go to number one, part B. Mars is a planet that may be considered to be an isolated uniform sphere of radius 3.4 times 10 to the power 6 meter. A satellite of mass 122 kilograms is in orbit around Mars at a constant height of 1.7 times 10 to the power 6 meter above the surface of the planet. The height of the orbit increased to 6.8 times 10 to the power 6 meter above the surface. This increased the gravitational potential energy of the satellite by 5.1 times 10 to the power 8 joule. Show that the mass of Mars is 6.4 times 10 to the power 23 kilogram. How am I supposed to do that? Make a
Change
suggestion.
in gravitational, change in GPE.
Since they work with energy, potential energy, we must work with potential energy, no? Right? That is what is given in the formula sheet. Right? This is the formula that we are using. Right? That's the formula that we are using. And then we take the GM out. GM out, G is 6.67 times 10 to the power minus 20. That's 11. And then small mass is 122 kilogram. That's the M. Then the final orbit. Okay, remember the R is the distance from the center to the satellite. So it's the height plus the radius. Right? That's the radius. That's the final height. And then the same for the other one. Right? It's a 3.4 plus that. Okay, there's a minus there lah. Right? It's a minus there, and then one is a minus. Right? Final minus initial. So we get that's the value. Then a lot of algebra involved lah. Can any question? Okay. Calculate the gravitational potential at the surface of Mars. Give a unit for your answer. That's why we have calculated. So we just use the other formula that is given. Right? This is the formula that is given in the formula sheet. Right? Surface is there's the radius of Mars. Right? The negative must be there. Okay, any comment? Stop me if I'm going too fast.
That's okay.
Satellite in B is moving to an orbit in which the satellite remains at the same point above the surface of Mars. The orbit has a period of 25 hours. State what can be deduced from this about the rotation of Mars on its axis.
Takes 25 hours to complete one revolution.
Okay, Mars takes just under 25 hours to rotate once on its axis. State one other feature of this orbit.
Moving in the same direction as the rotation.
Okay, orbit in equatorial or orbit in the
Rotation of
same
Mars.
direction of the rotation of Mars. Either answer lah. Usually there's at least one question in mechanic lah, either gravitation or circular motion lah. Sometimes they may have circular motion also lah. So now it's electric field lah. A bit of gravitation involved also lah. Helium atom may be modeled as a nucleus. That's a nucleus surrounded by two electron in diametrically opposite circular path, each of radius. That's the radius, 170 picometer, as shown in figure. Take Coulomb's law. Okay, see if you can remember without looking at your answer.
Q1, Q2.
Say again.
F
Take
proportional Q1, Q2.
Cannot use formula, I have to state it out. Electric force is directly proportional to the product of charges. Force between charges is inversely proportional to the square of the separation. Okay, memory work. That is the formula given in the formula sheet. State the charge on the nucleus in terms of elementary charge. Yep.
Plus 2E.
2E, okay. Show that the electric force between the nucleus and one of the electron is that this one is just applied Coulomb's law lah. Right? Coulomb's law. Write down the formula. That's usually worth 1 mark. And then 1/4 pi epsilon naught. Get from a formula sheet. That's the value. And then the nucleus is 2 electron, 2 charge on the electron lah. So that's why it's 2 times 1.6 times 10 to the power minus 19. The other one is the electron. Right? That's why it's 1.6 times 10 to the power minus 19 square. Then the radius is 170 picometer. Right? Change it to meter and then square. Okay with that? Happy with the answer?
Yeah.
Usually the answer is only 2 significant figure lah, unless they ask you for 3 or 4. Assuming that the force in figure B part 2 is the only force on the electron, calculate the speed of the orbiting electron. What formula should I use?
FE equals FC.
E equals to FC.
FE equals to FC.
That's the one that we have calculated. So we use mv square over r. Right? It's circular motion.
Yeah.
And subject v, right? Square root of fr divided by m. F is that value. Right? That's the radius. Right? Radius change it to meter. Mass, get it from a data sheet, mass of electron. Right? Remember this mass of electron, not mass of nucleus. Calculate the period of orbit. What formula do I use?
MR omega square.
Can also, or 2 pi r over v. Right? Distance over speed is your time for period. 2 pi. Right? That's the radius. That's the speed that we have calculated. Okay, anything you don't agree?
Okay.
Okay, let's carry on then. In practice, the orbit of each electron is affected by the presence of the other electron. Right? We calculate the force. There's an electron there that will affect the orbit of this electron. Or the position of one of the electron determine the ratio of electric field strength due to the other electron and electric field strength due to the nucleus. What is the formula
What's 2
used for
times
strength?
Q over 4 pi epsilon
Q over
square.
4 pi epsilon square, okay? So using this formula, write down. Usually it's worth 1 mark. If they have given you, then they won't give you the mark. And ratio, right? 1/4 pi epsilon naught is that value. Right? That's the electron. And then there's the R square. And then for nucleus, at the orbit of the electron, right? Multiply. So we have to invert it lah. So the radius there is 1/4 pi epsilon naught. This is the charge on the electron. Right? There are 2 of them. right? Two charge on the nucleus there lah. Electron charge on the nucleus lah. Okay. Any comment? Agree with my answer?
Yeah. Okay.
Use your answer in D part 2, part 1. You suggest and explain how the orbit of the electron is affected by the presence of the other electron. Yep.
You can say
It's a formula that you have been using, no? You have derived it just now when you calculate the speed, right? You suggest explain how the orbit of the electron is affected by the presence of electrons. So you can either state the speed or state the period, no?
force decreases when the radius decreases.
Resultant force is slightly
R decreases.
1.6, no? Right? Resultant force is slightly less than 1.6. So it's slightly less than the speed is lower, no? Okay, either answer. Anything not clear?
Okay.
Usually they will refer back to the formula that you have been using to reason it out lah. Okay, define specific latent heat. Without looking at the answer and remember offhand.
It's energy required to change state of matter at constant temperature.
Thermal energy. Usually they prefer to use thermal energy per unit mass
Per unit mass. Okay.
to cause
Change the state.
state change or change of state lah. Thermal energy to change the state at constant temperature without change in temperature lah, or constant temperature lah. Explain why a substance, for a substance, the specific latent heat of vaporization is usually greater than the specific latent heat of fusion. Make sure you got, this is a 3-mark question. So you need at least 3 points. Okay, what is your answer?
So larger increase in potential energy during vaporization. So there's also a larger increase in the separation of molecules.
2 mark only.
Also the temperature remains constant, so kinetic energy also constant.
Basic idea is for specific latent heat of fusion, you break the bond. Whereas for specific latent vaporization, you separate the molecule until the attractive force is reduced to 0, right? That means they are quite far away. Then you have to cause it to expand against the atmospheric pressure.
And the thermal energy is converted into potential.
Potential energy, no kinetic energy, involve greater change in volume of the substance. Volume increases. More work has to be done by molecules to separate. Kinetic energy of molecules unchanged, so more thermal energy needed. Okay, 3 points. You are right. The kinetic energy of molecule is unchanged. Anything not clear?
Okay.
Okay. There are other alternative answer lah. Okay, you can refer to that. It's not wrong if you say that. Ice cube of mass 35 gram at temperature 0 degrees Celsius is placed in a beaker containing water of mass 208 grams at temperature 26.4 degrees Celsius. When an ice has melted and all the water in the beaker has reached thermal equilibrium, the final temperature of water is 10.3 degrees Celsius. Specific heat capacity of water is that the beaker has negligible specific heat capacity and is perfectly insulated from the surrounding. Determine the value to three significant figures for specific latent heat of fusion of water. Right? So either you draw it out, what is happening, or you picture in your head of water at 26.4 kilogram, 26.4 degrees Celsius, ice cube at 0 degrees Celsius. After the mixture finally has a temperature of 13.3 degrees Celsius. Right? So heat gain equals heat loss. These are the formulas that we'll be using. Heat gain by ice to form ice water. Right? It's ice. To form ice water. Then ice water to raise the temperature of 10.3. And heat loss. Right? The water there goes to this temperature, you lose heat. So mass of ice. Right? They give it in gram. So you don't need to convert to kilogram. Okay? They use it in gram. This one is in gram. So your answer will also be in gram. Gram. And 37 gram times specific rate. This is water now. Water at 0 degrees Celsius times 10.3. There is a rise in temperature. And 208 water is water. Specific heat capacity of water, right, from 26.4 to 10.3. That's the loss. That's the fall in temperature. And okay, no? Okay or not? Okay, let's carry on. State what is meant by internal energy of a system. Can remember?
Uh, it's the potential plus kinetic energy.
You probably get 1 mark only, no? Sum of potential energy and kinetic energy and that energy or the total energy of the random motion of molecules of the random motion of particles. This is important. Random motion. Carry 1 mark. Explain why the internal energy of an ideal gas is directly proportional to the thermodynamic temperature of the gas. Yep. 2 marks means 2 points.
Zero potential energy because ideal gas.
Okay. Then
So basically, it's just internal energy is directly proportional to temperature.
potential energy of molecules in ideal gas is 0. That's your first point. So internal energy of the gas is equal to the total kinetic energy of the molecules. Kinetic energy of molecules is proportional to thermodynamic temperature. So internal energy is proportional to thermodynamic temperature. Okay.
Yeah.
Reason it out step by step. Right? That's the kinetic energy of a molecule lah, of an ideal gas. A sample of ideal gas at thermodynamic temperature T has an internal energy U. A gas is compressed so that its temperature increases to 3T. During the compression, work W is done on the gas. The gas is then cooled at a constant volume so that the temperature decreases to 2T. Complete table 4.1 to show in terms of W, T, and U, the work done on the gas, the thermal energy supplied to the gas, the increase in internal energy of the gas for each of the two processes. Right? Have a picture in your head, right? That is where you start with. Then you compress it. That's your work done. Then the temperature has increased to 3T. Then volume stays the same. The temperature changes to 2T. You cool it down. So that's the first law of thermodynamics. Usually they are more interested in the answer, but you can work on the paper. Compression, they are unlikely they'll give you extra paper to work. So work on the question paper. Right? That's what we have just said about ideal gas. U is proportional to T. So from that one to that one there, right? There's a change. Change in internal energy is 3U minus U. Then Q plus W. Right? That's a W. That part there. So Q is 2U minus W. Right? This 2U take over minus W. Right? Remember this compression, that's why it's positive. And cooling state, this state there. Right? Constant volume, no work done, no? So it changes from I got 10 more minutes there. Changes from 3T to 2T, no? Right? So it's U is proportional to T. So it's 2U minus 3U equals to Q. Right? So fill out the table. Okay. Anything not clear?
No.
Yep. Everything okay?
Okay.
You need to work. No choice. Work through the question. And then you work through from 22 onwards. You should be quite comfortable. But sometimes they repeat the question. Not all, part of it. Number 5. A cuboidal block floats in a liquid with a base horizontal as shown in figure 5.1. Right? There's a liquid surface, there's a block. The base of the block is at a height h below the surface of liquid. There's a base. It's the h below. The block is displaced downwards a small distance and then released so that it oscillates. Very simple harmonic motion. You can expect a question to come out in simple harmonic motion one. Every time will come out. Topic circular motion and gravitation will usually one question will come out. Okay, that's the graph. Determine the amplitude of the oscillation, what's the amplitude? No, the axis. Where's the origin? What's the amplitude? Subtract. Right? Either from here, right, to here, or from here to here. So this is 1.4, this is 0.8, so 0.6 meter. State what line in figure 5.2 shows about the nature of the oscillation. Yep. Yep. What's the answer? Okay, now oscillations are simple harmonic. Any comment?
Okay.
Okay, let's carry on then. State three other quantitative conclusion that can be drawn from figure 5.2 and 5.3 about the block and its oscillation. Use the space for working. This is the space for working. Yep. What are the three quantitative? Can use maths to calculate the value.
Total energy is 9 joules.
This amplitude, there's the acceleration from the graph. We can calculate omega. Right? Mean or equilibrium position is at h, so it's 1.4 meter.
1.4.
Total energy of oscillation 9.0 joule. Angular frequency of the oscillation, right? That's what we can calculate from the graph. Or these are others that can be accepted. Any comment? Anything not clear or anything you need me to explain further?
So
On figure 5.4, sketch a variation with the h of the potential energy EP of the oscillations. Right? They give you a scale, so you must follow the scale. Right? It's invert of the kinetic energy graph. That is the limit of the amplitude. Right? Make sure you don't exceed that. And then the highest point is there. Then it's a U shape. Can? Can or not? Anything need me to explain further?
no.
It's just the same as same as that, as that is inverted, right? Okay, let's carry on if there's no question. Figure 6.1 shows a circuit that rectifies an alternating input voltage, that's the input, and produce an output, that's the output V out, across a resistor with a capacitor there. The four terminal of the rectification circuit are W, X, Y, Z. Take what is meant by rectification. Yep.
Rectification. AC to DC. Alternating current to direct current.
Okay. Conversion from alternate AC to DC. What is the purpose of capacitor C? Yep, what's the purpose of the capacitor?
Smoothing. Provide smoothing.
Okay, no? Smoothing, good. Figure 6.2 shows a variation with time t of the potential difference V in and V out. Right, dotted line is your V in and the solid line is your V out. Lor. Variation with V in can be represented by this equation. Right? This is V in. A and B are constant. Determine the value of A and B if you need for your answer to A. Right? Draw the origin. Lor. And there's a standard equation for X. And in this case, it is V equals V naught cos omega t. Lor. So A is V naught. Lor. V naught is, right? That's the origin. Is 12 V naught. Right? Period from here to here is 20 millisecond. No? Right? Millisecond. Calculate omega. No? Omega is your B. No? It's 2 pi over T. Okay. Anything not clear? Less than a minute. Anytime will become.
Okay.
Okay. So we take 15 minutes break. Right?
All right.
Determine the type of rectification produced by a circuit in figure 6.1. Yep.
Type of rectification.
From the graph. No? Right? From the graph. Full wave. No?
Full wave. Full wave. Yeah, full wave.
Full wave rectification.